Chapter 5. Separation of substances. Most of the things around us like air, seawater, soil, rock, milk and paint are mixtures. Seawater is a mixture of salts dissolved in water. Milk is a mixture of cream or butter and water. A mixture is a substance that contains two or more pure substances mixed together in varying proportions. The substances, components, present in the mixture do not lose their identity. These components can usually be separated by simple physical methods. Milk or curd is churned to separate the butter from the water. Common salt that is used in our kitchen is prepared from seawater by separating salt from water. Let us study the need of separation of substances from their mixture. Need for separation of substances in a mixture. To remove undesirable substances. Tea is made by boiling tea leaves in water and then adding sugar and milk. After the tea has been made, used tea leaves are an undesirable component of the mixture. We separate it by using a filter called tea strainer. Before eating a banana, we peel off its skin, undesirable component. To obtain useful components. Crude petroleum is a mixture of various components such as petrol, diesel, kerosene, and petroleum gas. We separate the petroleum mixture to obtain these useful components. Kerosene is used as a household fuel, whereas petrol and diesel are used as fuels in vehicles. To remove harmful substances. We buy wheat, rice and pulses from the market. These food grains usually contain small pieces of stones and insects. These pieces of stones and insects are harmful to us. So, we separate them from wheat, rice and pulses before using them. Methods of separation. When we want to separate a component of a mixture, we should first find out some of its properties that would be different from the remaining components of the mixture. Let us study the simple methods of separating substances that are mixed together. You may come across some of these methods being used in day-to-day activities. Separation of insoluble solids from a mixture. Hand picking. The grains and pulses that we buy from the market may contain undesirable components like small stones. These components look very different from the food grains. They are of different sizes and colors, so these can be spotted easily. Such undesirable components can be removed by hand picking. Hand picking means to take out by hand. It is a convenient method of separation only when the size, shape, or color of the unwanted substance is different from that of the useful one. The quantity of the mixture is small and the unwanted substance is present in smaller quantities. Threshing. Cereals like wheat and rice are a source of food for us. After harvesting these food crops, the grains need to be separated from the rest of the plant. This is done by the process of threshing. The process of separating the grains from the rest of the plant is called threshing. It is done in the following ways. In manual threshing, the farmer holds a pile of crop in his hand and hits it against a rock or any hard surface. During this process, the grains separate from the plant. Threshing can be done by a machine called thresher. This machine is used for threshing large quantities. Threshing can also be done by combine harvester. Winnowing. After threshing, a farmer gets a mixture of grains, wheat, rice and husk. Now, before grains can be used, husk, undesirable component, has to be removed from them. This is done by using the property that grains are heavier than husk. The lighter husk particles are separated from the heavier grains by the method of winnowing. In this process, the farmer takes a mixture of wheat grains and husk in a winnowing basket. He stands at a higher platform from the ground and allows the mixture to fall down from a height by shaking the winnowing basket continuously. The wheat grains, being heavy, fall down vertically on the ground and form a heap. The husk particles, being lighter, are carried away by the wind, so the husk forms a separate heap a small distance away from the heap of wheat grains. In this way, husk gets separated from the wheat grains. The method of separating heavier and lighter components of a mixture by wind or by blowing air is called winnowing. Activity 1. To understand the process of winnowing. Things needed: flat plate thali, wheat grains mixed with tiny bits of paper, old newspaper. Method: spread a sheet of newspaper on the floor. Take some wheat grains mixed with the tiny bits of paper in a flat plate. Stand on a chair and allow the mixture of wheat grains and tiny bits of paper to fall down from a height by shaking the plate continuously. Observation: the tiny bits of paper, being lighter, are carried away by the blowing air, wind, to a greater distance. So, the bits of paper form a separate heap at a little distance away from the heap of wheat grains. Sieving: when the components of a mixture have particles of different sizes, a sieve can be used to separate them. A sieve is a shallow vessel that has small holes at its bottom. The size of the holes in the sieve depend on the size of the components to be separated. The method of separating the components of a mixture that are of different sizes by using a sieve is called sieving. Activity 2. To understand the process of sieving. Things needed: some wheat flour, some pulses, colored chalk powder. Method: take 100 gram of wheat flour and mix it with some pulses. Put the mixture of wheat flour and pulses in a sieve. Move the sieve back and forth repeatedly. You observe that the wheat flour passes through the sieve, but the pulses are left behind. Take 100 gram of wheat flour and mix it with colored chalk powder. Put the mixture of wheat flour and colored chalk powder in a sieve. On moving the sieve, no wheat flour or chalk powder is left in the sieve. Pulses were separated from the wheat flour in the first case, but chalk powder could not be separated from the wheat flour in the second case. The size of the pulses was bigger than the size of the holes in the sieve. Hence, the pulses could not pass through the holes and were left behind in the sieve, while the flour passed through the holes. In the second case, the size of wheat flour and chalk powder was smaller than the size of the holes. This allowed the flour and the chalk powder to pass through. Hence, sieving is used for separation when the components of a mixture have different sizes. Sedimentation and decantation. Insoluble substances that are heavier than liquid can be separated by sedimentation and decantation. Let us do the following activity to understand this process. Activity 3. To separate a mixture of sand and water by sedimentation and decantation. Things needed: 2 beakers, some water, some sand, glass rod. Method: take a mixture of sand and water in a beaker. Allow the mixture to stand undisturbed for some time. On doing so, you observe that the heavier sand particles settle down at the bottom of the beaker. This layer of sand is called sediment. When the sand settles down, or we say sediment is formed, clear water is left above the layer of sand. This process is called sedimentation. Pour the clear water into another beaker gently with the help of a glass rod, without disturbing the sediment of sand. This process is called decantation. When all the clear water has been poured out, only sand is left at the bottom of the beaker. Conclusion: in this way, a mixture of sand and water can be separated into sand and clear water, first by sedimentation and then by decantation. The process of settling down of heavier, insoluble particles at the bottom of a liquid is called sedimentation. The heavier insoluble particles that settle down at the bottom of the liquid are called sediments. The process of pouring out a clear liquid from a vessel after sedimentation without disturbing the sediment, heavy insoluble settled particles, is called decantation. The liquids that do not mix with each other and form separate layers are called immiscible liquids. Kerosene oil and water are immiscible liquids. Filtration. We have seen earlier that to separate used tea leaves from tea, we pour the prepared tea through the tea strainer. The tea strainer has a wire mesh in it that acts as a filter. The liquid tea passes through the small holes of the tea strainer and collects in the cup below. The used tea leaves, being bigger in size, do not pass through the tea strainer and are left on the tea strainer. This process is called filtration. The process of separating insoluble substances from a liquid using a filter is called filtration. The tea strainer cannot be used to separate mud from water. The particles of mud are too small and will pass through the holes along with water. For this, we need a fine filter such as a filter paper. A filter paper is a piece of special paper that has millions of tiny holes in it. The holes of a filter paper are so small that they cannot be seen with the naked eyes, but can be seen only through a microscope. Activity 4. To separate a mixture of mud and water by filtration. Things needed: muddy water, filter paper, glass rod, iron stand, funnel, 2 beakers. Method: take some muddy water in a beaker. Now, take a circular piece of filter paper and fold it twice as shown in the figure. Open it out to make a cone. Place this filter paper cone in a funnel. Now, clamp the funnel containing the filter paper on an iron stand. Keep an empty beaker below the funnel. Pour the muddy water slowly into the cone using a glass rod. The clear water passes through the filter paper and collects in the beaker kept below the funnel. The clear liquid obtained is called filtrate. Take out the filter paper cone and open it out. Mud particles can be seen on the filter paper. This is called residue. Conclusion: the mud particles, being bigger in size, cannot pass through the filter paper and remain behind on the filter paper. In this way, mud and water can be separated from the mixture by the process of filtration. Uses in everyday life. The process of filtration is commonly used in our everyday life. For example, fruits and vegetable juices are usually filtered before drinking to separate the seeds and the solid particles of pulp. For making paneer, cheese, a few drops of lemon juice are added to the milk as it boils. This gives a mixture that consists of particles of solid paneer and a liquid. The paneer is then separated from the liquid through a fine filtering cloth or a strainer. The tap water that we get from the waterworks can be made absolutely safe for drinking by using an electric water filter. Separation of soluble solids from a mixture. Evaporation. This method is used to obtain a solid substance that has dissolved in a liquid. Common salt dissolved in water can be separated by the process of evaporation. The process is based on the fact that liquids vaporize easily on heating, whereas solids do not. The process of changing of a liquid into its vapor by heating is called evaporation. Seawater contains a lot of salts. The process of evaporation is used on a large scale to obtain salts from the seawater. Seawater is trapped in shallow ponds called lagoons and allowed to stand there. The heat of the sun gradually evaporates the water completely in the shallow ponds, leaving behind the solid salts. This mixture of salts is further purified to obtain common salt. Activity 5. To separate common salt dissolved in water. Things needed: common salt, water, china dish, burner, tripod stand, wire gauze. Method: dissolve a teaspoonful of salt in about 50 milliliter of water taken in a china dish. Place the china dish on the tripod stand. The solution of common salt and water taken in the china dish is heated gently by using a burner. Observation: the water present in the salt solution evaporates to form steam. When all the water present in the solution of common salt and water gets evaporated, common salt is left behind in the china dish as a solid. Condensation. This method is used to obtain a liquid from its solution. We can get water from salt solution by this process. The process of changing vapor into its liquid state on cooling is called condensation. Activity 6. To separate water from a mixture of salt solution. Things needed: common salt, water, aluminium kettle, frying pan, beaker, gas burner, tripod stand, wire gauze, ice cubes. Method: dissolve about 20 gram of common salt in water to obtain a common salt solution. Pour the salt solution in the aluminium kettle and put the lid on. Place the kettle on the tripod stand. Also, place the gas burner below the tripod stand. Light the burner. Heat the kettle for some time. Steam comes out from the spout of the kettle. Take a frying pan with some ice cubes in it. Hold the frying pan in a slanting position, just above the spout of the kettle. We observe that when the steam comes in contact with the frying pan, cooled with ice, It condenses to form droplets of water on the underside of the frying pan. These droplets trickle down on the underside of the frying pan and then start falling down. Collect these droplets of water in a glass beaker and taste it. It does not taste salty. The water so collected is called distilled water. Separation of mixtures by using more than one method. A mixture that has only two components can be separated by a single method. On the other hand, a mixture that has more than two components can be separated into individual components by a combination of methods of separation. These methods are applied one after another. Let us consider some examples. Separation of iron filings, ammonium chloride and sand mixture. To separate a mixture of iron filings, chalk powder and common salt into individual components. Water as a solvent. Water can dissolve many kinds of substances like sugar and salt. When we dissolve a substance in water, a solution is formed. Activity 8. Can water dissolve any amount of a substance? Things needed: a beaker, some common salt, spoon. Method: take a beaker and put 100 ml of water into it. Add 1 teaspoonful of salt to this water and stir it with a spoon until the salt dissolves in it. Go on adding more and more salt in water with constant stirring to dissolve it. Observation: after adding a number of spoonfuls of salt, we observe that some salt is left undissolved at the bottom of the beaker. This means that no more salt can be dissolved in the amount of water you have taken. The solution is now said to be saturated. Conclusion: water can dissolve any substance only up to a limit. In the above activity, we have obtained a saturated solution of salt in water. A solution in which no more substance can be dissolved at a given temperature is called a saturated solution. Solubility. Different substances dissolve to different extents in water at a given temperature. For example, 204 grams of sugar can be made to dissolve in 100 grams of water at room temperature, whereas only 36 grams of salt can be made to dissolve in 100 grams of water at room temperature. In other words, sugar dissolves to a greater extent than common salt. The extent of dissolution of any substance is described in terms of solubility. The maximum amount of a substance that can be dissolved in 100 grams of water at a given temperature is called its solubility in water. Solubility of some common substances at 20 degrees Celsius is given below. Substance: solubility in water. Sugar 204 grams, common salt 36 grams, potassium nitrate 32 grams, copper sulfate 21 grams. Activity 9. To prepare a saturated solution of sugar at room temperature and observe the effect of temperature on the solubility of the sugar in water. Things needed: sugar, beaker, spoon, burner. Method: Take 100 gram of water in a beaker. Add a small quantity of sugar into the water. Sugar dissolves in water on stirring with a spoon. Keep on dissolving more and more sugar in the water with constant stirring until no more sugar dissolves. You find that some sugar is left undissolved at the bottom of the beaker. You have obtained a saturated solution of sugar. Now, heat the beaker containing the saturated sugar solution. What do you observe? The undissolved sugar at the bottom of the beaker gets dissolved. This shows that at higher temperature, more sugar gets dissolved. Now, let this hot solution cool. What do you observe? The sugar settles at the bottom of the beaker again. This shows that at low temperature, less sugar dissolves in water. Conclusion: heating of a saturated solution of any substance increases the solubility of the substance. If the saturated solution of a substance is cooled to a lower temperature, the solubility of the substance decreases and some of the dissolved substance separates in the form of crystals.